All right, let's get right into it. Today, we're talking about a programming language that's been making some serious waves in the tech world, Rust. And the reason everyone's so excited is that it claims to solve a problem, a really fundamental choice that developers have been stuck with for decades.
So, for as long as we've been building complex software, programmers have had to make this tough call. On one side, you've got languages like C++. They give you just raw, incredible speed, and that low-level control you need for things like operating systems or big game engines. But, and it's a big but, you're always living on the edge, risking these critical, nasty memory bugs. Then on the other side, you have languages like Java or Python. They're way safer. They have these things called garbage collectors that manage memory for you, preventing a ton of common errors. But that safety net comes at a cost. It adds overhead, which usually means your program runs slower. So for years, it was performance or safety. You had to pick one.
But what if you didn't have to choose? What if you could have it all? Well, that's the exact question that Rust was built to answer. It was designed from the ground up to completely shatter that trade-off. Rust's core promise, its entire reason for being, is simple but honestly pretty revolutionary. It's to give developers the power to build software that is both blazingly fast and memory safe. The goal is to give you all the performance of a language like C++ without any of those infamous bugs that lead to crashes and, even worse, major security holes. You know, the journey of Rust is pretty amazing when you look at it. It all started back in 2006, just a personal project by Graydon Hoare. But by 2009, Mozilla, the Firefox people, saw its potential and decided to sponsor it. The really big moment came in 2015 with Rust 1.0. That was the signal to the world that Rust was stable, it was ready for the big leagues. And then, in 2021, it became undeniable. You had tech giants like AWS, Google, and Microsoft all banding together to form the Rust Foundation, basically securing its future as a core technology for modern software.
So the big question is, how does Rust actually do it? How does it pull off this supposedly impossible combo of speed and safety? Well, the answer lies in a couple of really clever core concepts that are, you could say, its secret sauce. The first and most important idea to grasp is ownership. The best way to think about it is like a title deed for a piece of data. In Rust, every single value in your program has one, and only one, owner. And when that owner goes away, maybe a function finishes running, Rust automatically cleans up the memory for you. This one single rule is the entire foundation for all of its safety guarantees. It's that simple and that powerful. Okay, so how does Rust actually enforce that rule? This is where the magic happens. It doesn't wait for your program to run and then crash. No, it has this guardian built right into the compiler, and it's called the borrow checker. As you write your code, the borrow checker is constantly analyzing it. You can let other parts of your code borrow the data, but the rules are super strict. For instance, you can't have two different parts of your code trying to change the same data at the same time. And if you break one of these rules, the compiler just stops you. It won't build your program. For a developer, this is incredible. It means an entire class of really dangerous bugs are wiped out before your code ever even gets a chance to run. And this really gets to the heart of the difference. Those other safe languages, they use a garbage collector. It's a process that's constantly running in the background while your program is live, looking for memory to clean up. That's what causes that performance hit. Rust just flips the script. It moves all that hard work to compile time. Its whole ownership and borrowing system is what we call a zero-cost abstraction. And that just means you get these incredible safety guarantees without paying any price in performance when your code is actually running.
But you know, a truly great programming language is more than just its clever compiler. A huge part of Rust's success comes from its amazing ecosystem of tools that make developers not just productive, but actually happy to use it. Right out of the box, Rust gives you a world-class set of tools. Cargo is its build system and package manager, and it makes managing projects an absolute breeze. Crates.io is the central library registry where you can find tons of code the community has already built. And then you've got amazing tools like Rust.fm, which automatically formats your code so it's always clean, and Clippy, which is like a super smart assistant that points out common mistakes and helps you write better code. It all just works together beautifully. Okay, so a great promise and great tools are one thing, but is anyone actually using this stuff in the real world? Let's take a look at who's betting big on Rust. The answer is a huge, resounding yes. Get this. For 10 years in a row, Rust has been voted the most admired language in the Stack Overflow Developer Survey. What that means is that the developers who actually use it love it and want to keep using it.
That is some powerful feedback from the people who are actually in the trenches writing code every day.
And it's not just a fan favorite, it's being trusted in production by the biggest players in the game. AWS uses Rust for services where performance is absolutely critical. Google uses it in parts of Android and their Chrome browser. Microsoft is literally rewriting components of Windows and Azure in Rust. Companies like Cloudflare, Dropbox, Discord, they all depend on Rust to power core parts of their systems, the places where speed and reliability are totally non-negotiable.
This adoption is happening across the board, in all sorts of critical areas. Rust code is now officially part of the Linux kernel. That's the core of millions of servers in basically every Android phone. It's being used to build the super high-performance web services that power companies like Cloudflare. It's even shaking up web development with tools like Dino, and it's perfect for embedded systems on tiny devices where every bit of efficiency matters. Rust is, without a doubt, becoming part of the very foundation of our digital lives.
So, what does this all mean for the future? Well, Rust really represents a fundamental shift in how we think about building reliable, high-performance software. If there's one thing to take away from all this, it's that Rust has proven something that many people thought was just impossible. You do not have to choose between fast and safe. You can have both. And that simple, powerful idea is changing the entire landscape of programming. The impact is so huge that it's getting attention at the absolute highest levels. Just this year, the White House issued a report urging the entire tech industry to adopt memory-safe languages to improve cybersecurity, and these specifically called out Rust as a leading example. I mean, when the government starts recommending a programming language, you know a massive shift is happening. You know, Rust's success in just completely breaking this age-old compromise between speed and safety, it really makes you think. It just goes to show that with a fresh perspective and some really clever thinking, these problems we thought were permanent can actually be solved. And that leaves us with a pretty interesting question. If this fundamental trade-off can be solved, what other impossible choices in tech are out there just waiting for their own Rust-like solution? Thank you for joining this explainer.